Hi, everyone. Thanks for having me today. My name is Ryadh. It was cool to see the folks from Redis. So I'm Ryadh from the other fastest database. And today I'm here to talk about the state of SQL-based observability. And it's a very interesting topic, especially for me. I come from a bit of the same background. And before I start, I was curious if, just raise your hand if you use any observability system in the room. That's about a good crowd already. So let's talk about SQL-based observability, which is not a very new idea, but we'll see. I wanted to open this talk with a map. It's not very common, I guess, in tech talks to talk about medieval maps, but this one is pretty cool. First, it's actually from the Catalan Atlas of 1375. So it's a map from the Middle Ages. It's actually also a nice touch. We're here in Barcelona. And if you check this map, beyond the aesthetic aspect of it, you see the names of the cities are all kind of condensed towards the Mediterranean coast. So you see this coastline with all these vertical names on the coastline. It shows you the importance of this region, obviously, for civilization, for trade. It also shows you basically how active that part of the world was back then. And all these people were exchanging, traveling, trading. However, they come from different cultures. They speak different languages. They had different beliefs and religions. And they still found a way to create this emulation and trade and exchange. And that's basically what took us through the Middle Ages and everything else. And to do so, they had to agree on a common language. That's actually pretty cool, because they picked words from every language across the Mediterranean, and they came up with what we call the lingua franca of the Middle Ages, which is a trading language, something we use to trade from North Africa to the south of Europe to the Middle East. Some words of every part of that region made up this lingua franca thing that was used by traders to exchange and sell and develop the whole civilizations across the Mediterranean. Now, if you take a huge leap back to nowadays, what's the equivalent of the lingua franca in our tech space when it comes to manipulating data? Maybe you've guessed. Sorry, my clicker is not working. Yeah. It's SQL. It's the most standard way to interact with your data sets. And this year, SQL is 50 years old. So it was born in '74. And it's still standing, still around. People know it. Everyone learned it at the university, at school. It's actually a very simple data manipulation language. Simple algebra, simple operations. And in 50 years, other languages tried really hard to shake SQL out of its position. We all remember the NoSQL era and the NoSQL wars and all of what happened there. But it's still around. People still use SQL to manipulate their data, and it's easy to pick up, easy to work with, and easy to understand. But SQL, over 50 years, evolved towards different types of applications. I can spend maybe the whole presentation on this topic, but let's group them into two big categories. One of them is OLTP system for online transactional processing, which basically, the simple way to define it is the source of truth of your data, of your systems. It's the backend, it's the financial transaction, it's the records, it's the CRM data, it's the sales data. It's very operational, and we manipulate rows, and we want very strong consistency properties, asset properties there. And SQL evolved to support that, and different SQL systems were built to support that. On the other side, a parallel track happened with analytical processing systems, systems that sole purpose are to answer questions. So you put your data there. You don't really manipulate individual rows. What you're looking for is insights at scale. You want to group by things you want to like detect phenomena, and what you're interested is really understand what's happening in the broader data set. So often you store your data differently, and often all app systems are column-oriented. So this is like quickly the brief history of the systems. You write a query, you get your answer. At the end of the day, no matter what data you put in there, as long as you get the value out of it. So for example, here, there's observability data stored in a SQL store. Now let's talk about observability. Sorry, it's not like I want to go to the Middle Ages again for observability, but we'll start from a more recent history. It's a simple idea as well, understanding the status of a system based on some signals it's outputting. And it's not a new idea as well. Can anyone tell me what are we looking at in this picture? Don't know. Any proposal? Calendar here? Sorry? Recipe? No? Navigation. Yeah, we're getting close. It's actually for navigation. Every vessel has one of these. It's called a log book. And it's basically stemmed from the word of like ships and exploration. It's very simple. The captain writes a date, some coordinates, a status, a message like this happened on my ship today, and then they keep adding to the logbook. It's actually a mandatory thing if you sail any large vessel to have one of these. And as a data structure, it doesn't really differ much from a log file that we still use nowadays. It's actually the very same idea, a journal of events that you are storing. Obviously, we produce way more events right now, so people have thought about, I'm managing a huge infrastructure. Do I really want to go to each piece of infrastructure and look at the individual stages? Probably it's better to like centralize everything in the same place, and this idea of like centralized logging was born with systems like syslog, for example. But they really thought about the mechanics of like moving the data around, and not really about how do we store and query this data efficiently. Again, many years later, 2013, Twitter was growing at an exponential rate. Everyone was like opening accounts, many billion tweets per day. And they had to manage a huge infrastructure of servers to serve this use case. So they built their own observability system. It's actually a very interesting story because it was so big they could not just like pick a vendor and go with it. They had to build something custom to manage this use case. They use Cassandra. There's like an interesting architecture behind it. But you see that when the use case was like large enough, probably no commercial solution can achieve the desired purpose. And then open source. Open source did its magic everywhere, obviously. We have Linux, we have other systems that are open source that we use, Kubernetes. This magic also extended to the observability use case more recently with the OpenTelemetry project. OpenTelemetry, for the first time, provided a simple standard for the collection and the management of telemetry data from various types of systems. So it's a set of SDKs. It's a binary for collectors that can export this data. The good thing about it is that it's not opinionated. So it can export this data to like databases, proprietary systems, search-based systems, column stores. And for the first time, we have a standard to work with. Because for many years, every vendor tried to like lock everyone in its like systems by providing the agents and providing everything. Here we have a vendor-agnostic approach. So the big intro was really to land into this slide, which is telling us basically that data systems evolved. Now we have very fast databases that are SQL-based, especially real-time all-app systems. The observability stack also evolved towards more standardization, and the open source did its magic there. So there is like a unique opportunity right now for what we define here as SQL-based observability, which is just basically treating your data as your observability data as any other data set. So I come from ClickHouse, which is a real-time analytics database for the OLAP use case. As I said, one of the fastest database out there, very efficient. We'll talk a bit more about the properties. So you'll see that in this talk, I'll really focus on ClickHouse because it's what I know better. But the ideas in this talk are applicable whatever you pick, as long as the database you pick respects the same properties, all right? So it's pretty open as an idea. And the idea is as simple as that. If you have this like setup and standardization, then observability becomes just another data problem. And we've been solving data problems in databases for years. You don't need an end-to-end solution. You don't need like a vendor that like designed all the buttons for you to get your graphs and alerts and collection, etc. You just need efficient way to store, represent, and query data. And what allows that is some OLAP properties that you'll find in ClickHouse, for example, but you might find also in other systems. The first one is this real-time aspect. We want to get notified about what's happening in the system as soon as it happens, because that's the whole purpose of like an observability system. So the system needs to be very fast and needs to have the ability to ingest huge volumes of data efficiently. In ClickHouse world, it's not uncommon to see millions of events per second. We have even like benchmarks at billions of events per second in the single environment. And this is a property that allows basically to manage a large amounts of data in a single cohesive environment. Now this data is in your database. You don't want to be spending millions on disks for storage. So you need a system that's capable to perform good compression on your data. And in that area, not all systems are equivalent, depending if the data is indexed, for example. For search, it might even expand the volume of data on disk. At ClickHouse, we made the bet of like a very efficient data compression, especially applied to the observability and telemetry data. It makes more sense because there's a lot of redundancy in these data sets. Think of your levels in your log lines. Think of the host names that are always the same, etc. Some standard messages that are info that always are populated in your systems. Another interesting property is the separation of storage and compute. It's simply the idea that now with efficient object storage, you can have compute nodes, but actually they store the data behind the scene on object storage. And this decoupling allows for seamless scalability and kind of almost like a bottomless storage. Disks are limited in capacity and fragile. Object storage has very strong availability guarantees with some trade-offs, obviously, but separation of storage and compute really opened up the realm of what's possible to store in a single environment. Another very important aspect is the interoperability, which in fact comes from, in the case of observability, some of the standardization around OpenTelemetry, but not only. So you have your data in a database. If it's just there sitting, it's almost useless. But you plug in Grafana, you plug in your custom application, you plug in OpenTelemetry, you plug in, you name it, some alert manager, and then it becomes a live system. And you can really pick the right integrations for the job you want to achieve. And finally, extensibility, which means that you're not stuck in a model where the vendor defined everything from end to end, every scenario, every alert, every anomaly detection, every query. Here, you just deal with data, whatever the format is, whatever the location is, as long as you can ship it, move it around, and query it, your use case is fulfilled. So, in short, every observability pipeline will look the same. There's a collection phase. Then the data lands into some kind of storage engine that can answer queries. And then you need dashboards, you need TVs in your monitoring room, you need alerts, etc. So this pipeline, when it comes to the SQL-based observability pipeline still holds and still applies, and this is a kind of example architecture. Not the only architecture possible, but one of the many architectures you can have. As I said, in that case, for example, we bet on OpenTelemetry at the collection layer. The project is thriving, CNCF project with many, many contributors. We at ClickHouse officially maintain the ClickHouse exporter for OpenTelemetry. So we back it and we stand behind it. And the idea is like in OpenTelemetry, you can deploy like collection agents and also gateways that are like aggregators. And this OpenTelemetry collector can then send your data either directly to your data store, whether it's ClickHouse or something else, or if you want like strong delivery guarantees, you can also use some kind of third-party queuing system, like we used Kafka as an example here. However, it's not mandatory, depending on your use case. On the consumption part of the data, you can use a UI. We can pick an open source project like Grafana, for example. Grafana has a ClickHouse data source that we also officially support at ClickHouse. And we took great care actually making sure this data source is OpenTelemetry native, since we have a standard to work with. So instead of like giving you a very open experience, it's pretty opinionated. And if you have OpenTelemetry data, it works out of the box without any additional configuration. Grafana is actually the most popular UI, obviously, for observability use cases. But not the only one. Other projects are popping. Just last week, this company called HyperDX published an open source project, very cool one. Talk about it a bit more later. That works with ClickHouse. Perseus is also another CNCF incubating project that's working right now with Prometheus, but that's we're working with them, and they're working on like extending their set of available connectors. Pretty exciting project. Superset, which is like originally for BI and more of like the classic data visualization tooling, but a graph is a graph, and as long as you get the results you need, that should work. But not only, you can write your own apps. You can really customize everything because you are in an open environment. So just pick a language client, Python, anything, and write your app that's interacting with your observability data, train a model, detect anomalies, do predictive maintenance. It's up to you now and not up to the vendor that controls your pipeline. This is the example of the Grafana experience. As I said, it's an opinionated experience. On the left here, you see the kind of the setting screen with all the OpenTelemetry predefined schemas, and just using it gives you an out-of-the-box experience for logging and tracing. But the new players entered the scene and embraced this model. Like I talked about HyperDX, a young startup, and they built this project recently, which is a UI for ClickHouse for observability. As you can see, they embrace SQL because SQL is really like predominant in the experience. Data is stored in OpenTelemetry format in a ClickHouse database. You can get to see your logs, you get to see your traces, you have access to all the features you expect from an observability platform, filtering, querying, alerting, dashboarding, etc. And it's a pretty fast and smooth experience. And that's what I referred to earlier in the context of OpenTelemetry as the open source magic, basically. Like some people, when the systems are open, some people will just take care of it at some point. All right, let's now take some real-world examples of people that are running SQL-based observability at scale. The first one I picked is Uber, who deployed a fairly large OLAP data store for their logging use case. As you can imagine, they generate tons of logs. So they decided to write custom log shippers. They use Kafka as a buffer or a queuing mechanism for delivery guarantees in this case. ClickHouse as a data store, and they wrote a custom connector for Kibana. As you might know already, Kibana is part of the Elastic Stack. So usually it works with the Elasticsearch, but they had to like kind of tweak it because their users were trained to use Kibana. And what they want with that is they had a highly scalable system which can index and ingest data at very high speed while keeping the costs under control thanks to the great compression properties. The trade-offs, obviously, is that now you have an infrastructure, you need to administrate it, and they had to build a custom UI in their case because they did it a few years ago, and their users were already trained on something like Kibana. And if you check the resulting architecture, the layout is a bit different, but it's pretty much exactly the one I described earlier as a reference architecture. Kafka, custom ingester, ClickHouse, querying can go either to the UI or to a custom API. A very open system where you can just decide how to store and consume the data. Let's take another example here. eBay, also a fairly large tech-oriented company. And here, they made the OpenTelemetry bet pretty early on, actually, because nowadays, like, OpenTelemetry is mature, and people are not really afraid of getting OpenTelemetry. But back then, it was not really the case when they used it. So they picked the project, they used ClickHouse, and they built a custom UI on top of it. What they want is amazing data compression for their observability signals, the open source model licensing. The trade-offs they had to make, obviously, is managing a fleet of OpenTelemetry collectors. At the scale of a company like eBay, it's a significant undertaking. However, a company like eBay is also not really scared managing a fleet of agents. Resulting architecture, same thing. Every Kubernetes clusters that's running apps is embedding the OpenTelemetry SDK that's producing tracing events. There's an OpenTelemetry agent, or the collector here, that collects everything. It goes to the trace store, and then everything is exposed to the users. They call this platform share lock. Last example is, for me, easier to talk about because it's our own use case inside ClickHouse. So ClickHouse as an OLAP database is an open source project. You can take it and just install it and run with it on your server, or you can just subscribe to ClickHouse Cloud or managed service for ClickHouse. That's differentiated in many ways. The main one is the separation of storage and compute, and which means that we have customers at ClickHouse. We have many, many of them, and we do need to observe this huge deployment. And what we've done, obviously, we're dogfooding our own solution. We use ClickHouse to observe ClickHouse, deploying a bunch of OpenTelemetry agents, ingesting data into ClickHouse clusters, and observing the data with Grafana. And the wins are fairly obvious for us. We know ClickHouse pretty well, so it's not very scary for us. But just for the fun, we tried to compare with if we used like a commercial offering for that, and we would have paid something around 26 million a month for the same amount of data stored. The trade-off, obviously, is that we needed to put engineers on the ground to build and maintain this stack, and we wrote a blog about it. Architecture, not very different from what I displayed earlier. Every Kubernetes node is running an OpenTelemetry agent that's taking care of collecting what's happening from the pods of that node. Then there is a bunch of gateways that are aggregating the Kubernetes node's output and then sending it to Loghouse. That's the name of the system we built, which is just a ClickHouse cluster. And we use Grafana to visualize this data. As of now, I think we've been running this platform for less than a year. As of now, we have 43 petabytes of data under management in Loghouse, which is key for us to be able to operate ClickHouse Cloud. As you can see, every day we generate close to 1 trillion rows. And the main thing I want you to really remember from this slide is that these 43 petabytes of data are effectively using 2.4 petabytes of storage on disk. And that's what I was referring to as the cost efficiency of something like ClickHouse, the efficient compression, since telemetry data contains a lot of redundant information, compression applies really well to this problem. From a usability perspective, it boils down to who are your users, who are your ops people, who are your SREs, and what they want to use. So let's write a simple query, right? I want to isolate the logs that have the level warning. So that's a filter. And I want the average duration by level, which is a group by. And I want the top 10 sorted by duration. So not a huge ask, to be honest. But on the left, you see here the Splunk query language version of it, which is pipe-oriented when you custom query. Many people are trained to do that. On the right, you see the Elasticsearch version of the same query. That's also running the same kind of aggregation, but with other convention. I mean, that works, but I kind of like this one. It's not that sophisticated. It achieves the same purpose. It's an idea of like usability and ergonomics. Some people can get it, some people can't. We don't want to force anything on anyone, and we are running a very open platform. We know SQL, but nowadays it's not very hard to even generate SQL. You don't need to know SQL. So that's ClickHouse Cloud. I have this table in ClickHouse Cloud, and we released natural language processing there. So instead of writing my SQL query, I can just say, get me these data points that respect this query in plain English. And we trained, obviously, a model here to generate that. It's trained on ClickHouse documentation. It knows every function. So I guess the barrier for entry for something like SQL, which was already pretty low, is now lower than ever. And it's easier for people to generate. As well, you don't have to take my word here for granted. You can also try yourself and compare different systems. Part of the open source ecosystem as well, there's like system that can transpile any query language to SQL, like HyperDX that we saw earlier. So now, a bit of like forward-looking things. So the way we approach this use case at ClickHouse, as I said, is an open kind of platform integration play. So we are the engine in that model. OpenTelemetry is the collector, Grafana or HyperDX or others are like the visualization layer. So we influence and we kind of contribute to both ends of the story by maintaining these projects and contributing to them. But in ClickHouse Core, we also make a lot of improvements that not only apply to the observability use case, but sometimes makes a lot of sense in the context of telemetry data. For example, we recently released semi-structured data support in ClickHouse with the JSON data type. It's a new feature, and what it allows you to do is just to send a bunch of JSON data to ClickHouse that will take care of how to store and represent it and model all the object tree into the database as classic fields. Usually, that's pretty challenging. Some systems are better at this than others, especially like NoSQL systems, which were built exactly for this use case, like document store. But in the context of OLAP, it's a fairly advanced feature, and it unlocks a lot of things. Is that if you just declare your field as JSON, then you don't need really to think a lot about your data modeling, and the ergonomics of the use case are improved. This feature was released 2 months ago, and it's still in experimental state, but we plan to upgrade it to beta next month. Another feature that's part of the core, ClickHouse core, is what we call the time series table engine. It's a special kind of table engine. Taking a step back, as of now, ClickHouse is a very interesting story for logging and tracing. A bit more challenging when it comes to metrics as a use case. So we said in that area we need to make investments. People are trained to use things like Prometheus to manipulate their metrics, so we want to be aligned as well there. And the time series engine is a way for us to represent metrics data, but also to expose this metrics data through the PromQL query language. So this is also experimental and will allow basically to complete the observability story. However, in the meantime, you don't have to use this experimental feature. The open architecture we described earlier also allows you to combine different data stores thanks to OpenTelemetry versatility. So you can run Prometheus, Thanos, Victoria Metrics, you name it, if you want for your metrics use case. And you can pick the best tool for the job, depending on what your use case is. So that was it for me. We have around 10 minutes for questions. Thank you. Do you have any questions? Thank you.
Just two quick ones, I think. So one was like the 43 petabytes database. What was the engine?
The 43 petabytes?
Yeah.
Where we store this data?
Yeah, yeah.
We store it on ClickHouse.
It was
directly in
ClickHouse.
ClickHouse.
Just in case it was Prometheus or something.
No, it's generated by our ClickHouse cloud, so the customers running ClickHouse themselves on our infrastructure, and we collect everything. It amounts to 43 petabytes now, and it's growing. And the good thing is that it costs us only 2.4 petabytes of storage, and because of compression, and we still are able to operate this infrastructure and monitor our customers' environments.
So it seems people don't believe that. Well, don't believe them. They believe, but you know, it's impressive.
Yeah, I have access to the platform.
Yeah, no, I mean, we trust you. Don't get me wrong. And the other one was like, okay, so we're talking about OpenTelemetry, but who monitors the monitoring agents, or what advice would you give to people? How do you monitor that your monitoring works, you know, in a way, like which is a complex question because it's another monitoring system probably, no? So
yeah, that's a good question. It depends on now the deployment strategies you pick and the type of pods you run and the types of environments you run. Not everyone is running on Kubernetes, but if you are on Kubernetes, there are like some specifics you need to know, stateless nodes versus stateful sets, and many things you can do to improve the way you lay out your infrastructure. Unfortunately, there's no single answer. It comes to like deployment best practices, failover scenarios, handling and management. And sometimes if you really, like if your telemetry data is really sensitive, it means like your company lives by the availability or not of a system, then as always, we recommend redundancy. And having more than one way to collect the data is a way to achieve it. So OpenTelemetry can be your main pipeline, and you can have like sidecar kind of collection pipelines that are there only to guarantee the most sensitive data availability.
All right, so I think that was it. Thank you, Ryadh. Thanks for your talk.
Thanks, everyone.
Thank you.